Okay, S2, Chapter 1, continuous random variables. First off, just look at the chapter heading itself. Continuous. What does the word continuous mean, either from your knowledge from S1 or from GCSE?
Can be any value in a range.
Can be any value, yeah, okay, great. Can be any value. So it's not restricted. Any value in a range. Okay. What's the opposite then of continuous? Discrete. Okay. Random variables. What do you know about random variables? Have you come across discrete random variables? Does that ring any bells?
Rolling a dice.
Rolling a dice. Okay. If you roll a dice, what can you have?
1, 2, 3, 4, 5 or 6.
You can have a discrete number of outcomes. And what can you associate with each outcome?
A probability.
A probability, yeah. So random variable is something that can take multiple values. So it can take multiple values at random, and it has associated probabilities. Okay. So what you should have done in S1 was discrete random variables. And the thing that Sam mentioned already was, for example, rolling a dice. Rolling a die if it's singular. If you were doing this and you would lay it out a special way, what was the proper way we could lay something out about this, the information that we have for this? If you were just thinking back to S1 and rolling a dice and the multiple values and associated probabilities, how might you draw it out? Probability table, yeah, okay. You would say maybe that X is the value on the dice, or on the die, and then you would say X can take various different values, which we use as lowercase, and they would be 1, 2, 3, 4, 5 and 6. Then you say the probability that the random variable takes those values would be 1/6 if it was a fair die. And this thing here, what was it called when you had it drawn out like that? Can you remember? 2 words, one beginning with P, one beginning with D. Yeah, that's good. That's right, okay. Once it's like that, that's probability distribution. Okay, so this is a recap from S1. The capital letter is the name of your random variable, and the lowercase are the values it can take, okay? So uppercase was used for the name of the random variable. And lowercase was used for its values. If I was going to graph that, what do you think would sensible labels on the axes might be?
X and probability, big X is little x.
Yeah. Okay. And what sort of graph would I get? What would my graph here look like? Straight line.
Bar chart with flat tops.
Bar chart, flat tops. Yeah, you would get here something like that, where that was 1/6. Okay, that is a discrete distribution. Okay, the values it can take, each value has an associated probability. What do we know about the probabilities?
Add up to 1.
Add up to 1. Yeah. Okay. We know that the sum of each of the probabilities adds up to 1. What else do we know about each of the probabilities?
They're all equal.
In this example, they're all equal, yeah. Just for anything, even if that didn't apply. Can you think of something they could never be?
0.
Could be 0 if it was impossible, but they could never be. You're very close. They could never be less than 0. Yeah, okay, that's right. So probability could never be, could not be less than 0. Okay, so that's some discrete stuff. So coming into continuous stuff, so switching now into continuous random variables, which I'm just going to call CRVs for continuous random variables, otherwise you'd spend an awful lot of time writing down long words. What do you think a graph of a continuous random variable will look like?
A line of some sort.
A line of some sort, okay? So a line of some sort, okay? X will be down here. Going with the definition we had earlier on for what continuous was, maybe between two values you had probabilities. So you'll get something like this now for continuous random variables. If there happened to be a value between A and B, which I'm going to call C, what would be the probability that X equals C? And from the information you have got, you should be able to give me the answer as a number. Maybe I'm pushing my luck. Maybe I'm pushing my luck a little bit there. The probability that X equals C. Let's say that that was 2, that was 4. Let's say that X is the length of a pin. Okay. So let's say the question was, what's the probability length of the pin is 3? Let's talk with, maybe we're doing it in centimetres. What's the probability the length of the pin is 3? Anybody going to have a go? 0. Why?
Because to be that exact, you're taking infinitely small, like it. Yeah.
Well, you're going exactly the right line, yeah. With continuous, no pin can ever be exactly 3. If you measured it, you know, even with better equipment than actually you could, it would be 3 point something, 0, something, or 2.99999 something. Okay? We actually say that the probability with continuous stuff that it takes any value is 0. Okay? So the probability here that it was 3 is 0. You cannot have probabilities taking specific values. Okay? Specific value probabilities just don't happen. So the probability X is any specific value will always be equal to 0. Okay? So that's one key thing about continuous random variables. So rather than deal with specific values, what do you think we might deal with instead?
Range of values.
Range of values, yeah. So what we do instead is we use ranges. We use ranges. So if we had said what's the probability that the length of the pin was between 2.95 and 3.05, that would have been perfectly acceptable question to ask, okay? That's an okay question to ask within a range. What's the difference between these two lines? I'm just going to pause the recording there. First of all, the last question was, what's the difference between these two lines here? Will they have different answers? Will they have the same answer?
Possibly, but
Because you're only excluding two specific values, which again have the probability of 0.
That's exactly right, yeah. Here, you're including 2.95, which is a specific value, but it has a probability of 0, according to this anyway. And here, whether we include or don't include 3.05 doesn't matter. So those two lines there would have exactly the same answers, okay, if you're doing continuous data. So those two lines there are equivalent. So we had the suggestion a minute ago that we integrate. And yeah, that is actually what we do. So if I do this sketch again here, let's say that x equals the length of a pin. And let's say x only exists between 2 and 4 centimetres. And there's my function, 2 and 4 on x. Now, on the y-axis, we use usually f of x. F of x would be the probability density. And picking up on what Sam said a minute ago, if I wanted to find the probability that the length of this pin was between 2.5 and 3, which I'd write down like that, you can find 2.5, you can find 3, and what you do is you find that area. So you are integrating between those limits, whatever your function is, with respect to x. What would the equivalent have been with discrete distributions? Where we're integrating here with continuous distributions, what would the equivalent have been with discrete distributions? What's the discrete version of integrating?
Just the sum of the probability.
Yeah, just adding up. Yeah, that's right. Okay. So if you want one of Mr. White's famous red box rules, okay, there we go. To find the probability, it lies between two values. You integrate your function between those two values. Now, we said something else earlier on. I think it came from somewhere over there. Earlier on, we had this bit here. All these probabilities on the dice added up to 1. Can anybody come up with maybe an equivalent statement over here for this continuous example? You're looking very nervous, but you want to have a go. Get on.
Integrating the entire range will give 1.
Integrating the entire range. If you integrate from minus infinity to infinity, which should cover the entire range, of your probability function with respect to x, you get 1. That's exactly right. Okay? That's the equivalent of they all add up to 1 in discrete. Okay? And if you're doing an A-level question on this topic, it's that fact that you often use first in the question. So, if I do a first example with you, and we'll just see how we go. Okay? So, x is a continuous random variable. This is the last time I'm writing these 3 words down here as well, with a probability density function. That's like its equation, if you like. Probability density function, which we will hereafter just call a PDF. And you'll see it probably written down like this. So you've got your function, you've got what it is, and you've got the limits it is that. It's that between minus 2 and 2, and it basically has no value elsewhere, so it doesn't exist outside that range. What do you think the first part of this question might be? And if we can have somebody who hasn't spoken up so far, that would be really good. What do you think the first part of the question may be?
Find K.
Find K, that's exactly right, yeah. Part A of the question typically would be find K. Okay. So, Chris, what you need is on the board. What do you think I would do then to find K? because those are my limits. Yeah. What am I integrating?
Your function k for
Yeah.
and that equals 1.
Yeah. Don't forget to put the dx there. And yeah, that equals 1. That's right. Okay. So, testing your integration skills. What can we do to make that easier right away?
Expand.
I wouldn't expand, to be honest. What might make it easier to deal with? Easiest thing, or the best way I would suggest starting, is take that k, which is just a constant number, take it through the integral sign. Okay, take that through the integral sign. It's not a variable, it's just a number. So I can take that straight through the integral sign. Now, where could I put that k next, maybe? Where could I move it to next? Yeah, I can move that k next onto the other side. Okay, so I'm going to move that k to the other side of the equals in a minute. Okay, so that k will appear over here as a dividing k. So that's where that has ended up. And then I need to do this integration. So Hannah, can you integrate 4 minus x squared for me, please?
4k
Not 4k, because we're integrating with respect to x. Yep.
minus k.
The k's out here, the k's over here now. K's vanished for a minute. Don't worry about the k. Can you integrate x squared?
A third x.
Yeah, that's right. Okay. So they've done the integration, 4x minus x cubed over 3. I'm doing it between the limits of 2 and minus 2. What would happen next if I was doing integration, Matthew P?
You would put those values in and minus.
Yeah, I'll put those values in. So first of all, I'll substitute the 2 in. So I get 4 lots of 2, take away 2 cubed over 3. Then I will substitute the minus 2 in. Okay, and if you can work that out, you will find out what 1 over k is, and then you should be able to find out what k is. So I'm just going to pause the video there. Yep, so over here we should have had 32 over 3 equals 1 over k, which means that k equals 3 over 32. So the first part of the question usually would be to find k. So then what we can do is we can go and rewrite our PDF now. So continuing here, our PDF is going to be 3 over 32, and then we'll need a stop, 4 minus x squared, and 0, that's between minus 2 and 2, and 0 elsewhere, or otherwise whatever word they want to use. And that, I think, is where we are going to have to stop today, because the bell's about to go. So this is where we got to last time. We had found this value of k to be 3 over 32. We rewrote our function. Our function existed for x between minus 2 and plus 2. It didn't exist anywhere else. And then today, the first thing is finding a probability then that x lies between 0 and 1. This line here means not including 0 and 1. This line here means including 0 and 1. Just off camera we mentioned that that's actually the same, because there's no specific probability for any value anyway. So whether these extra bars are on there, it really does not matter. They are identical, okay? Because the probability with any specific value is 0. So we've got our function. I want to know the probability lying between 0 and 1. Can somebody tell me the calculation that I need to do? Off camera we have had the key fact that we need told to us. So the probability x lies between 0 and 1. What do we do for that? I'm going to ask somebody who hasn't got their hand up. I am going to ask, first of all, Chris over there. What do we do?
You integrate between 0 and 1.
Yeah, you integrate between 0 and 1. that function. Okay, so you all should be pretty good at integrating. Can we go ahead and do that integral and get the answer? I'm going to stop talking but keep on filming, so I'm going to freeze your screen, but those watching can still see what happens next. Okay, so the next thing is finding the median of a continuous random variable. Think back to S1, think back to GCSE. What is special about the median? Matt, what's special about the median?
Middle value.
It's the middle value, okay? So if we think a minute, we have some function, say it's limited to be between A and B, and we have epsilon here and fx up there. We said the median is the middle value. Can anybody maybe think how we could apply that to this scenario that we've got here? Ben?
The centre of the range.
Sorry?
The centre of the range.
The centre of the range. Not necessarily the centre of the range. You've got to bear something else in mind. You would just sort of say halfway between the two of those. It's not that. It's not just halfway between those two. You've got to bear in mind
Is it half the area?
half the area. Yeah, that's right. The area between there is going to be 1. So what you're trying to find is the point M, which is the median, where the area over here is a half, and equally the area over here is equal to a half. Okay? Now, if your distribution was particularly skewed, say it went from between A and B there, it definitely wouldn't be the midpoint of A and B because you'd have more area on the right of it than it would on the left. Okay? If your distribution looked like that, then yes, it would be bang in the middle of A and B because it's equally distributed everywhere. So, if it's this, can anybody give me a statement I could write down involving integration, that A, that B, that M, and that half, like a sort of fact or a statement for the median?
It would be halfway between A and B for that one, wouldn't it?
For this one here,
Yeah.
it would be, yeah. But generally, for this sort here, where it's not necessarily. Ben, would you have a stab at that? You can pass if you want to. You'll pass. Okay, go on.
The median is point M such that integrating between M and A is equal to B and M.
That's correct. That's correct. But can we maybe get away with not mentioning A, M, and B?
Or M and A is equal to half, or B and M is equal
Yeah.
to half.
Okay. You're integrating from the lower limit that there is up to the median, the function, and you know the answer to that integral is a half. That is like the definition of the median. So you integrate your function from the lower limit up to this M, which is what you're trying to find out, and you set the answer to be a half. Okay. So we're going to have a look at an example. We're going to use a different PDF, a different probability distribution function this time to what we were using before. It's going to be ax minus 4x cubed for x taking values between 0 and 1, and it's not going to exist anywhere else. So let's call it example 2. So we want to find the median. Can we just go and do that straight away? Hannah or Lily, can we just do that straight away, or is there anything we need to do first?
You need to find M.
Not, and that finding M will be the median. There's something actually written down here we need to find first.
Energies work out A.
We need to work out A. Yeah, the first thing we'll do, it's a bit like the first question we started off with last time. If there's a letter over here, a constant, that will be the first thing. So what we're going to do here in this question, part A is going to be find the value of constant A. Part B is going to be find the median. Part C is going to find the probability that x lies between 0.1 and 0.6. And part D is going to be find the mode. If you think back to what the mode is, you might be thinking where we're going to go with that in a minute.
Would there be brackets around x minus 4x cubed?
Here,
Yeah.
there's no need to. There, I'm only cubing the x.
No, I think so.
But between x minus 4x cubed, because then a would be times by both of them.
Yeah, but it's only something else.
Yeah,
Okay.
yeah, that's meant to be a times by x. Take away 4x cubed. Okay. So the first thing is finding the constant a. Can anybody tell me what key fact did we use last time to find the missing constant? I am going to go back to Hannah and Lily. Have you got your notes from last lesson with you, you two?
Yeah.
So there's one bit that I highlighted, showed it on the board this morning. How did we find the constant a? What did we do to find that constant at the beginning? What fact did we use?
You moved it outside the, like, next, out of the...
Outside the interval.
Yeah. And what else went on at the same time? That's not the most important bit. That's part of it, but
It was equal to 1.
yeah, that's the key thing. Yeah, integrate it equals 1. So for part A, to find the constant, I know that if I integrate my function between my limits, which are 0 and 1, I will get an answer of 1. So that is what I am going to use to do this. So I'm going to integrate ax minus 4x cubed dx between 0 and 1 and set the answer at 1. Right, Mr. Lomax, are you happy to integrate that for me? Ax minus 4x cubed.
That would be a over 2 x squared minus x to the 4.
Okay, that's right. That's the integration bit, okay? The limits are between 1 and 0. Set that equal to be 1. I couldn't take the a straight out this time because it wasn't multiplied by everything in the integral. It was only multiplied by a bit of it. So Lily, do you know where we would go next? The clues with that.
You'd put 1 into...
That's right. Substitute the x to be 1. So I get now over here a over 2 times by 1 squared. So that's just a over 2. Take away 1 to the power of 4, which is just 1. So that's what I get when I substitute my 1 in. What am I going to get, Lily, when I substitute 0 in?
Yeah.
It's 0.
Minus 0.
Yeah, you're going to get 0, take away 0, which is 0. So the other one is just going to give you 0. I know that's equal to 1. So basically here I've got a over 2 minus 1 equals 1. So Hannah, what would I do now then if I were to work out what a is? What would my next step be?
Get rid of, like, times everything by 2.
I could times everything by 2, so I'll get a minus 2 equals 2.
And then get out AX and
So a equals
4.
4. Yeah, okay. So I now have a equals 4. And what it's probably very useful to do after that is write down again what your PDF is. I'm going to do it because it's gone off my bit of paper anyway. So I now have my PDF to be this. Okay. So I found A was 4. I've now got my PDF. Are you all happy with what we've done there so far? Okay. So what did I say part B of the question was going to be?
Finding
Find the median, yeah. And we had a box that we wrote down earlier in today's lesson that we are going to integrate our function between the lowest value it can be, which is 0, and m, the median, which we have to find out in a minute. And when we integrate it, we're getting an answer of a half. Liam, would you be happy to tell me my next written line from here?
I'm going to just integrate 4x minus 4x cubed with respect to x, which will equal 2x squared minus x to the power 4.
Okay, yeah, put the limits in here, the naught and the m. We still know that equals a half. You've done the integration bit here as well. Yep, just let everybody catch up with what's gone on. If you already worked through this bit and got the answer. Okay. So, what Liam's done here, he's done the integration. Gary, could you talk us through the next line? What I'm going to do now?
You would, in the bracket, well, in two sets of brackets, do one for m and one for 0.
Yeah, that's right. Substitute the m into here, and I get 2m squared minus m to the power of 4. When I substitute the naught in, what's going to happen, Gary?
You don't get anything.
Don't get anything. And that's equal to a half. So I've got an equation here that 2m squared minus m to the power of 4 equals a half. I've got to solve this equation. I'm going to stop the video at this point and I'll carry on in a different clip. So we've got this equation. How do we go about solving equations with powers of 4 in them?
You use a vertical substitute.
Why will that be helpful? You are right. Why will that be helpful?
So that you can have a quadratic.
Yeah, that's exactly right. Good. As long as you've got m to the power 4 and m to the power 2 and no m cubes or m's and things, yeah, you can change it into a quadratic. What letter would you like to use?
I put y.
Y, okay. So I guess you're letting y equal m squared?
Yeah.
Okay. Then this line here becomes 2y minus y squared equals a half. That's a quadratic equation which you know how to solve. How would you go about solving this now in an exam? Can't you just type in your calculator and now it pops the answer? So you can, can't you, these days? If you've got the graphics calculators. Okay, so whatever way you do it, you've got to set it equal to 0. So I'll move my minus y squared to the other side, because I don't like minus signs in front of quadratics. I'll move my 2y across, that will change sign to be negative. My half will still be there and be positive. And then you have to solve that. You can solve that any way you like. You can solve it by completing the square, you can solve it by the formula. Maybe it's even possible to solve it by factorising. But looking at the answer I've got down here, it isn't, because it's nasty. Has anybody solved that then somehow and got an answer for y?
I've got y plus or minus half root 2.
Yeah, I've got written down here, very close to what you said, I've got that is my answer for y. Okay? You're nodding, is your calculator just giving you that by typing it in?
Yeah.
Yeah, okay, so it does that these days. When I was at school, we didn't have calculators, it did this for us. Okay? So y is equal to that. If you type it in your graphics calculator, that pops out. But remember, we're not interested in y, we want m squared. But m squared is equal to y. So m squared is equal to this.
Plus or minus?
Yeah.
Well, it's not solvable, which is fine.
Well, up here you want a plus or minus. Okay. So, what I need to do now, well, what do I need to do to get into what m is?
Square root of 1.
Square root that, yeah, okay. And if you square root that, I know all that is as a decimal, I've got it written down here. Does anybody else have that worked out as a decimal? Go on.
0.541.
Yeah, 0.541.
That's only when you minus.
Yeah.
Okay. Is there another answer you get as well?
Yeah, but it's outside the 0 to 1 range.
Yeah, that's
so
right,
you're
yeah.
right.
You may well get two answers, but that's right. The median has to be between 0 and 1, because that's the only values x can take. So if you get another value that's outside that range, just discard it, you're not interested in it. The answer here has to lie between 0 and 1, because x has to lie between 0 and 1. Everybody want any more discussion on that, or can we move on? So part C was find the probability that x was between, that's x there, 0.1 and 0.6. Is there anybody we haven't heard from? I don't think we've heard from you, actually, have we, Matthew? Well, other than I got a short-term memory. Matthew, can you tell me how I will work this probability out? It's between these two ranges.
You integrate between 0.1 and 0.6.
Yep, you integrate between those numbers. And what is the function I'm dealing with from earlier on? Shall I tell you? Rather than you say it turning over a page, it was that. Okay, that's the function we're dealing with. Now we've got to integrate this, but somebody already did it earlier. Was it Liam who integrated it for us earlier, I think? Liam's already told us when we integrate that, we get that. Now again, I can see people tapping away on calculators. You can just type that in the calculator and it gives you the answer, can't you?
Yep.
Okay. God, back when I was a boy, we had to do this properly, working out. So, okay, you can just type that into a calculator, you can do the integration. Do we have an answer then, folks?
1141 over 2000.
Whoa, can you tell me that's a decimal? All I've got down here is a decimal.
0.5795.
Yeah, that's what I've got written down here, okay? I've got, when you substituted the 0.6 in, it was 0.5904. When you substituted the 0.1 in, it was 0.0199. You guys can just type that line into a calculator for a definite integral and get the answer out. Is there anybody here who has not got a calculator that would do these integrals for them?
Yeah.
Okay, ask Father Christmas to come early in the summer holidays. It will save you an awful lot of time. Okay, part D.
Because you've got the already integrated thing in. Oh yeah.
Part D was find the mode. Now, I haven't talked about how we're going to go about finding the mode. I am going to pick first of all on Ben W and say, Ben W, what was the mode when you learnt it at GCSE or even Year 9? What was the mode? The most common. What do you think? How do you think that might be interpreted? Now we are dealing with continuous functions, maybe looking something like this. What do you think the most common might be interpreted to mean?
The highest point on the graph.
Highest point on the graph, yeah, that's right, okay. So the mode is the highest point on the graph. The highest point on the graph inside our range. So, if we had the graph sort of looking like that, the mode would be that value down there. Okay? So, how do we go about finding the highest point on a graph?
dy dx equals 0.
Exactly, yeah, that's right. Differentiate your function to get dy dx, set that equals 0. So, how do we find the mode? Find the mode, you find dy dx, you put it equal to 0, and you solve that for x. Okay? So, it's a red box rule, but in a green pen. How do we find the mode? You differentiate it, dy dx, set that equal to 0, and you solve that for x. So that's exactly correct. A reminder, because it's off the screen at the moment, f of x is 4x minus 4x cubed. So if you haven't done it already, differentiate it, set it equal to 0, solve it for x. I'm going to stop talking and freeze what you're looking at, but the video will still see what's going on. I'll just make a comment that when you do get here, you may well get two values again. If one of them is outside of the allowed range, you cannot have it. And that is why you'll see it in a minute if you're in the class. I'm only getting one answer. I'm discarding one of them because it's outside of the range. And at that point, I'm going to pause that video. Okay, so next we're looking at finding the mean of a continuous random variable. And before we do that, I want to take you back to the work you did in S1, where you were looking at discrete data. You used some notation for the mean, that the mean was the expected value of x. That should be ringing some bells to you. What was your formula you had for the expected value of x from a discrete probability distribution?
Which one?
Just the sum of the probabilities times
Yeah. Sum of each probability times by the value of x, all added up. Yeah, okay? So, that was the discrete version. That's a formula you're familiar with. So now we are looking at the continuous version, and we want a formula for the expected value of x. Well, what is sigma going to be if we are now talking in continuous data? Sigma was adding up discrete things. What will that be if we're moving into continuous land? Integration. Okay? Integration is just adding up lots of infinitesimally small things. So the summation sign becomes an integral sign. What is our probability denoted by in continuous random variables? It's not denoted by p. What have we denoted it by? F of x. Yeah, f of x. Okay? And the x is still going to be there. Normally put it at the beginning. Okay? We're integrating with respect to x. That is the formula. But if we're integrating, we need some limits, and I'm going to put on here minus infinity and infinity. Okay? It's basically the extent of the values that you can take. So that is a formula for the mean when you are dealing with continuous data. It follows on basically from the formula you had from discrete. And before we do an example, what we're going to look at next, what did you learn about after the mean? What was the next thing you probably learnt about? The variance. Okay, so let's look at that a minute then. So finding the variance of a continuous random variable. And let's approach this the same way. What was the formula you had for the variance of a discrete probability distribution? Sigma
X squared pi minus mu squared, where mu is
the expectation of x. Okay, so is that what you're saying? Because that's correct. Yeah, okay, that's correct. Okay. Did you have another bit of notation you sometimes used for this thing here? Sigma x squared times by p.
Oh, yeah, we did. I can't remember it, but we did.
I remember the thing, I don't remember what letter it is.
If that is the expectation of x, that is the expectation of x squared. Yeah. So, did you ever come across that formula for the variance in discrete? Okay? It's the same thing, it's just sort of written in a different way. The expectation of x squared, take away the expectation of x, force of breath, squared. Okay? So, if we're going to look at this now from the continuous point of view, okay, use what we've got on the top half. What do you think this will be here, the expectation of x squared into the continuous land? What will this be?
Integrating between infinity minus infinity x squared f of x.
Is it spot on? Correct, yes.
Minus
Okay, so that bit there is this bit here. Okay, and then we still take off the mean squared. And we know to work out the mean because that's in this box up here. Okay, so what is in here is your formula for finding the variance for a continuous random variable. The red bit I will refer to as the expectation of x squared sometimes, so you do need to know that bit there as well. Okay, and it matches up perfectly with the discrete version that we had. So now we've got that other information, we'll see if we can work through another example and we will use that. We will have our function f of x, which is going to be kx between 0 and 1. It's not going to exist anywhere else. What's part A of the question going to be? You can all say it at once. Part A of the question is going to be... That wasn't everybody at once, that was one person. What's part A of the question going to be? Find A. Yeah, okay. You'll get used to these questions. So find K, not find A, I think I said. Okay. Then in part B, we will go and find the mean. And in part C, we will go to find the variance. There's our question. So, finding K, what key fact will we use to find K?
the total.
Between 1 and 1.
Yeah, you integrate between your limits, which here are 0 and 1, your function with respect to x, and you know the answer is 1. Okay? So, now we've found k to be equal to 2. Part B, finding the mean, or you may want to use the notation, the expected value of x. The formula we're using is we're going to integrate x times by our function, integrate between our limits. Okay? So, I'll leave you to do that. I'm not going to talk through a bit. Again, I'm going to freeze the screen in the classroom, but not on the video.
Same with rank correlation coefficient.
If anybody has the mean, you can shout it out if you want to.
I didn't know one was right.
What are you
So, for those of you in class, the calculation for the mean is on the board if you want to check anything.
Oh, I was finding the median.
And now I'm going to go and carry on the video to do the variance. I'm going to do it in 2 bits. I'm going to work out expectation of x squared first.
Doesn't need you wrong yet, because I think it'll work out.
I don't know. 2 squared. Times it by x and x squared. That's
Stearman's rank correlation goes, I think.
That's why.
And I'm going to pause the video at that point. So, for the sake of the video, to get the mean, I'll just unfreeze that in class as well, it was integrating y times by our function between the limits. You can take the number through the integral sign to make life easier, do the integration, substitute your limits numbers in, and you do get an answer of 0. For the next part of the question, the variance, that's the notation that I'm using. It's the expectation of y squared, take away the expectation of y squared. That's the formula for the expectation of y squared times by the function being integrated. Put your limits in, and you'll see the rest of that in another clip in a minute. Okay, for the sake of the video at the moment only, variance of, we said, was the formula here, expectation of y squared, take away the expectation of y all squared. So that's putting the y in front of your function, integrating it between your limits. Again, I've taken the 3/32 outside. That's the integration done. That's a 3 up there. Substitute in, and you get the value for the expectation of y squared. Remember, that's not the answer. That is just that bit there. You've then got to take the expectation of y away from it, squared, although we did work out that was 0, so actually here it makes no difference, but that wouldn't always be the case. So the next bit, probability that y was greater than 1, is integrating from 1 up to the upper limit you've got of your function, which we've done here. Again, you can do that on a graphics calculator if you want to. And the last bit, any specific value, that bit is 0. Okay, in continuous random variables, we are going to look at some specific distributions. The most famous one is what we're going to deal with in Chapter 2, which is the normal distribution. There's another one called the uniform distribution, and when you're doing miscellaneous exercise 1, it actually features in question 6. If you look at that one, question 6, you've just got a completely flat distribution between two values, and that is the uniform distribution. Now, there is a shortcut which will speed up your work on that, which I'll tell you about in a minute. But if we just demonstrate first of all by means of an example what the uniform distribution is, it has a constant probability between two values. So if we have a variable x going along the bottom, our probability denoted as f of x going up the side, it exists between a and b and it's flat. Now, what's the area of this rectangle here got to be? 1, yeah, because all the probability is there between A and B. So the area of that rectangle is 1. What is the width of that rectangle? The width of that rectangle is B minus A. Now, the height times by the width equals the area, and that equals 1. We've just said the width is B minus A. So what must the height be to make this statement over here correct?
The inverse of the width.
The inverse of the width. So what do you... Just rearrange this equation. To make h the subject of this equation, what happens to that B minus A over here? Yeah, it's timesing over here. dividing over there. So that's what the height is. The height is 1 over b minus a. So for the uniform distribution, its PDF, f of x is, well, it's 1 over b minus a when x lies between a and b, and it's 0 everywhere else. So that is its PDF. Now, just using common sense and looking at it, what do you think the mean of that distribution is? Don't think formula or calculating, just think common sense. What do you think the mean of that distribution is?
Is it halfway between A and B?
Yeah, just talking sort of layman's terms, it's halfway between A and B. So the mean is here. Now, what sum can you do? What calculation in terms of A and B can you give me that will work that out for you? Yeah, A plus B divided by 2 is the average of A and B. So you add them together and divide by 2. That is the mean of a uniform distribution. Okay? There's also a shortcut for the variance in that, I mean, you could use a normal formula if you wanted to work it out. But if I tell you the variance of the uniform distribution is b minus a all squared over 12, and that it's useful to remember that because it will save you some work. There we go. Okay? So, main things here. This is called the uniform distribution. That's basically its PDF. That's its mean. That's its variance. If you learn those, it can save you a little bit of time sometimes. If you haven't learnt them and it crops up, the normal formula you know for continuous random variables apply anyway. So it's not the end of the world if you don't remember them. But if you can remember them, that's just an added bonus. So I just want to run through one more example of continuous random variables. It has a slightly different feature to it this time. In that f of x, what's normally in f of x at the beginning of any question? Yeah, find k. So some letter we've got to find out. But here, there are two letters that we have to find out. We're going to have to find out a and b in a minute. We know that's the function, and that exists between 0 and 2. It doesn't exist elsewhere. But we've got two unknowns there, so we do need some other information. We are also told that the expectation of x is 1. And what we have to do is to find A and also to find B. So that's the question here that we are dealing with. So, what red box rules, what important things that I told you in previous lessons could we use, do you think, here to help us identify what A and B are? How do we normally kick this off if I want to find out what k is?
The integral of the top equation equals 1.
So we have the integral of the function equals 1. Okay, that's going to be important, yeah? What else do you think we could use then? What other information did we have in the question? The expectation of x equals 1. So can I write something down a bit like this over here? For this one? The integral of x f of x also equals 1. So I've got these two things. Where do you think this question is going to go? What sort of direction is this going to go, and what are we going to get?
Get something in terms. Yes, simultaneous equations.
Simultaneous equations, yes, spot on. Okay. So over here, the integral of our function. So over this side, we're saying if I integrate ax minus bx squared with respect to x, between the limits, which are 0 and 2, I get an answer of 1. I'm going to split the page a minute down here. Then on the right, if I integrate x times by my function, so if I increase all the powers on x, then again, between my limits, I also get 1. So I am going to end up here with two simultaneous equations. And if I solve those, I will find out what my A and my B are. Is everybody comfortable with what I've done so far? Okay, Gary, could you do the integration of the one on the left, please?
would it be a over 2x squared
Yep,
minus b over 3x cubed?
yep, it would. Okay, add 1 to the powers on the x, divide by the new powers. Evaluated between 2 and 0 equals 1. Okay. So when I substitute in, when a is 2, I'm going to get here 2 squared, which is 4. Divided by 2 is 2, so I'm going to get 2 lots of that a. And here, 2 cubed is 8, so that will be minus 8/3 of b. That is what I get when I substitute 2 in. What will I get when I substitute 0 in? And 0, yeah, because there's a 0 there and 0 there. Okay, so what I get down here is 2a minus 8/3 b equals 1. That is an equation, no integration in there now. That's an equation for that one. So, can I have a volunteer to do the integration on the one on the right? Mr. Lomax, thank you.
You would get ax cubed over 3
Yep.
minus bx to the 4 over 4.
Yep, okay. And again, put the limits in, 0 to 2, that's equal to 1. So, 2 cubed is 8. 2 to the power 4 is 16. Divided by 4 is 4. When I put 0 in, I'm not going to get anything again. So I end up with this equation. Now at this point, what are you going to do? What will you do at this point?
Find A times B.
That's the long way round.
Oh.
On your graphics calculators, can't you just tap these coefficients in and get the answers out? Okay? Because it's S2, you're allowed to do that. So if you get your graphics calculators out, I think you just tell it you're doing a pair of simultaneous linear equations and give it the coefficients of the first one are 2 minus 8/3 and 1. Whether you've got to set them equal to 0, I'm not quite sure. You guys need to work it out. But if you solve those on your calculators, if you tell me what your calculators say the answer is, I'll tell you if you've got it right or not.
A is 3 over 2, B is 3 over 4.
A is 3 over 2 and B is 3 over 4 is correct. Okay? So if you've managed to get that out of your graphics calculator, you've put the right stuff in. Okay? So that was just another example there of something slightly different where you have to bring a different area of maths in to get an answer to that question. So one final example on continuous random variables. Here we've got a PDF not in its normal 2 parts, but this one is in 3 parts. It's kx for x between 0 and 2. It's k into 4 minus x between 2 and 4, and it doesn't exist elsewhere. I'm not going to go through the whole thing, I just want to make sure you know how to tackle this. And it might just be sensible, first of all, just to do a sketch of the function, so you know the sort of thing that we're looking at here. 0, 2 and 4 are interesting values on the x-axis. When x is 0, what is the value of f of x? Yeah, because k times by 0 is 0. So it goes through that point there. Okay, now looking at the top bit here, what's the value of f of x when x is equal to 2? Which is the end of this interval. When x is equal to 2, what's the value of k of x? 2k, yeah, okay. So here, it goes up to 2k. And what sort of curve is it between 0 and 2? Someone said it? It's a straight line, yeah, okay. Y equals kx, it's a straight line. So that looks like that. Now, it also has a 2 allowed here. So what's the value of f of x over here when x is equal to 2 in this second bit here? If you substitute here x is equal to 2, what do you get? Yeah, you get 2k again, so that makes sense. It sort of carries on from there in this bit of its definition. When x is 4, there's an interesting point. What is the value of this when x is equal to 4? 0, yeah, because 4 minus 4 is 0. So it comes down here. So it looks like that. Okay. Now, what do we know about this triangle's area? Must be equal to 1. Yeah. So you could literally do half base times height and set that equal to 1 to find out what k is here. Or alternatively, if it wasn't a nice shape, if it really was sort of one curve here and another curve here, the principle we've used before still does work. So the general method we've used before of integrating our function and saying it must add up to 1 works here, but you just have to split it up. So if you wanted to say that the function k of x, that's what it is between 0 and 2, and then it changes to be k into 4 minus x between 2 and 4, and the area there equals 1, all you need to do is just add those two bits together, and that would work. So if you get them split over different bits, you can just do each bit separately. Although in this one here you could just have used half base times height for the area of the triangle, set it equal to 1. I'm not going to finish it. The whole point of that one was you can get them in 3 bits, you can get them with different things. If you want to do it this way, that way still works. Okay. Okay, so one final example on this. We're starting with, what's it called when I write down this thing here to start with? What's this called? This is a probability distribution function, or probability density function, yeah, a PDF. Okay, it's ax into 6 minus x all squared between 0 and 6, and it doesn't exist anywhere else. So we're going to find various things out according to this distribution. We're going to find pretty much all the obvious things, I suppose, really. So what's the first thing we expect to find? We expect to find A, yeah. So the first thing we will do is we're expecting to find A, and what key bit of information will we use to find A, Gary?
We'll use the fact that you integrate between the lower and upper limits and it all equals 1.
Yeah, integrate between the lower and upper limits, our function, and we expect the answer to be 1. So that's what we're going to use. Right, I won't talk you through that. You do it, I'll do it. I'm sure you can do this pretty much as well as I can, or I hope you can anyway. Of course, you can just do it on your calculators, can't you? If you take the A outside, you can just then do it on your graphics.
No, it wouldn't be.
It's just before the exam.
Do we have a value for A from graphics calculators?
We got 1 over 108.
That is the right answer, okay. So,
I think it was 4 times 6 before. And that was on
Which-
minus.
where have we gone?
Yeah, when you have x to the 4 and x to the 5, it should be x3, x cubed and x to the 4. So you've added a somewhere.
There.
Oh yeah, you've added that power like last time.
What?
Because you've got 12x
I don't know.
cubed.
Yeah.
We're just,
Thank you.
I don't remember.
Shocking. Monday morning. That's what I'm blaming it on.
No.
Yes, it's being
Okay.
filmed. It's appalling, isn't it?
Us when they...
Yes, they can
Oh,
hear you.
okay. So one has to be like safe for work.
That's right.
Got this wrong.
Yeah, they're saying the word.
Honestly.
That's
That's 4.
Is this M1?
Oh, I thought
Got that bit right.
future names.
There we are. I think I've done my corrections. It is A is 1 over 108. Okay, I think I know corrected that if anybody wants to check.
Yeah, because we were in the...
Yeah. If you're using a graphics calculator,
That probably might get.
Yeah.
that bit there you can just evaluate straight on your graphics. On the graphics calculator. You see if you're making all sorts of horrible errors I just did.
type in x and with the bracket 6 minus x will go.
So you're telling me, yeah, you can actually go up to that line there on the graphics calculator. Yeah. Okay. Fair enough. Right, so we've got A. So let's hide that horrible bit of paper. Littered with mistakes.
Because if it,
Yeah, I didn't tell them.
We're okay to move on. So we are here. I'm going to write out our function again at this point. Always a good idea to do that. A was 1 over 108. Right, so there's our new function. What do you feel like doing next? The mean. Okay, let's find the mean next. Right, so Gary gave us how we did it last time. Could somebody else tell us then, how do we find the mean?
integrate between upper and lower limits x f of x.
Yeah, that's right, x, f of x. So, if I'm smart this time, and just write down the graphics calculator bit, and pretend I've got one, what you're integrating is that. And if you bung that into graphics calculators,
1296 over 5.
say that again.
1296 over 5.
It's not what I've got written
Oh
down
no,
here.
I should have done the correction.
Maybe you hadn't got the 108 in the beginning.
I think that's
Is
it.
it
Yeah, I
12 over
did.
5?
It is, yes. Okay.
Alright, go into go back. Go and run.
Oh, there we go.
Go and run. Hey, there we go. Okay, next. That's not good.
Okay, so graphics calculators really do come into their own on these, as long as you key things in correctly. So we found the mean. What should we do next then?
Variance.
Oh, had debate with the mode or the variance. I heard mode first, so let's do the mode next then. Okay. Then we'll do the variance afterwards. So if we're finding the mode, what do I need to do to find the mode? What's like my red box rule, if you like, for finding the mode? What is the mode? The highest point. Yep, so what we're doing here is finding the highest point. And how will we go about finding the highest point? Differentiate it, so we'll find dy dx, if we call this thing up here y, And what do we do when we differentiate it?
Look for the 0. Gradient equals 0.
Yeah, so put that equals 0 because that's the gradient, and then we find what x is. That makes that true. Okay? So that's the process we're going through. What sort of equation are we dealing with? Our y is what sort of equation over here? What sort of an equation is this?
So, cubic.
A cubic equation, yep. So it's either going to look like that, or it's going to look like that. So it might give us two turning points. Well, it will probably give us sort of there and there. Or if it's this way around, it will give us that one and that one. And then if it gives us two answers, we just have to find which x value gives us the greatest y value. Okay? So if you were going to differentiate this, which you're not allowed to do on calculators, because that would be symbolic differentiation, how would you start off if you were going to differentiate this?
Expand out.
I would expand out, probably. Yeah, I think it's probably the easiest thing to do here, is expand out. So that bracket I multiplied out earlier.
Product rule would be easier.
Product rule easier?
Product would be easier than change.
You'd have to use both.
Well, yeah. Okay.
Yeah.
There are various ways of doing it. Okay. So if you multiply it out like this a minute,
Using product, you would end up using.
if we multiply it out, we get that, or you could leave the 108 out as a factor, probably tidier and nicer if you leave the 108 out as a factor. Because what we need to do is set that equal to 0. So either the 1 over 108 equals 0, which is clearly not true, or the bracket equals 0. Now, what do you do from there? How do you go about solving cubic equations? On your calculator, yeah, you just go to your graphics calculator. My guess is, do you have to sort of rewrite it in order, or just think of the coefficients?
Yeah, you would.
Okay. So,
Yeah, you would.
sort of think of it like that, maybe.
Yeah, you probably differentiate it.
And then we do x square, and then we don't need to.
At least we haven't differentiated it yet, have we? I'm having a bad morning. I'm going to delete this video later on. Yes, right. So,
Standing up gets very good.
it's not working for me. It's not working for me. So, right, we had our... Let's put that bit of paper over there. We had our function. The ironic thing is, if I actually just looked at my notes and checked that I was doing it right, we wouldn't get in this mess. Right, so, what have we got here? We have our function. We're supposed to differentiate it. Here we go. Let's differentiate this. We need dy dx. Here we go, this looks more like it. It's a nice quadratic we've got to solve.
Remember when quadratics are really hard?
No.
They still are.
Oh, you.
So do you all get those two x values? Whichever way you've done it. Now we need to work out which of those is a maximum and which is a minimum. So if we substitute those into here, if x is 6 and we substitute it into the line at the top of the board, what's y going to be?
0.
0, yeah, quite clearly because of this bracket here. Stick 6 in, y is going to be 0 there. Now all we need to know when we stick 2 in is whether it's going to be positive or negative. That's enough information. When we stick 2 into here, that will be 4. So it'll be 4 squared is 16 times by 2, that's positive, divided by something positive. That's going to be positive. It's going to be greater than 0. So the x equals 2, 1 is going to be the maximum, because it's got a higher value than this one over here. So we can conclude that our mode equals 2. We all happy with that?
We want 0 to be the point of 2 on y.
If you stick,
Did you do that?
there's our function.
3 times 2
Hang on.
squared minus 24 times 2 squared. So it's 0.
What are you doing? So you put it.
Oh, so
you should have put it in the original.
2 squared. That's 2 squared. I think we need
Did you put it into the differentiated function?
Yeah. No. Yeah.
Yeah.
Pretty sure you would. Yeah, that would make sense, wouldn't it? Because it's a solution to no.
See, standing up for you on a Monday morning isn't good. That's proof. Right, okay, so we have done finding A, we've done the mean, we've done the mode. The next thing that somebody suggested was the variance. So there's our function, and we have to find the variance. Okay, how do we go about finding the variance? What's the red box rule thing for the variance?
Sigma. No.
Go on, Andrew.
X squared fx minus the expectation squared.
Yeah, I think you said the expectation of x squared minus the expectation of x all squared.
Yeah.
Or you said x squared f integral of that.
Yeah.
You said, yeah, which
Yeah.
is the same things effectively. Okay? So yeah, that's what we're doing. And we know that this expectation of x here, we worked that out earlier on to get the mean. And the mean was 12 over 5. So we know that expectation of x is 12 over 5 from earlier. So this bit here, we need to work out now. Integrate between our limits, x squared times by our function. And that's the thing you can just plug into the graphics calculator. So I'm not going to make a fool of myself this time, hopefully. And I'm going to say, using a graphics calculator, we know the answer to that is
Oh, 36 over 25? Wait, that's the whole thing, isn't it? 36 over.
Oh yeah, that's the whole thing.
That should be 36 over 5.
Yeah, that's 36.
36 over 5.
Yeah.
I agree with you. Okay, that thing there, that bit there, first bit is 36 over 5. So to get my answer for the variance, I said it's expectation x squared, take away the expectation of x all squared. Someone's told me that's 36 over 5. Earlier we worked out that that was 12 over 5. That needs squaring, taking away from that, giving us a final answer of 36 over 25, also known as 1.44. Okay, so we found A, the mean, the mode, the variance. Anything else? Median. You could do the median. Okay. What do we have, or how do we rather go about finding the median?
Integrate between 0 and m equal to a half.
Yeah, that's right. Integrate our function between its lower limit and m, which is what we've got to find out, and set the answer to be a half. You can't do this on your calculators, can you? Nope. Got to do this properly. I think the reason I didn't do this one before is because you end up here with a quartic equation.
Does anyone's calculator solve quartics?
I'm hoping you're all about to tell me yes, and the answer is, because I haven't got the answer, I don't know what it is, I haven't done this before. Do your calculators not do quartic equations?
My graphics calculator can.
So you may need to write it out.
Mine, if I type in polynomials, only goes up to 2.
How do you do it?
But if I type in the equation and choose x4...
Is there a quartic equation?
It's like a massive.
So you may need to sort of write it out like that and now solve it on the graphics calculator. This would not happen at A level. There was a reason I didn't do this one before. But if you can solve that on your graphics calculator and get an answer out, we know our answer's got to be between 0 and 6. So if it comes out different to between 0 and 6, we've gone wrong.
Why don't you just try all the values between 0 and 6?
Try all the values between 0 and 6. How many values are there between 0 and 6, James?
No, I mean, you could start like 3.
So how many values are there between 0 and 6?
About 7.
7.
I mean,
You said 7, someone said infinite. There's a slight difference between those values.
No, actually, no. There's 12, isn't there? Because there's also the like 0.5, 1.5.
Yeah.
Oh no, there's actually 24. Isn't there? I don't think it goes further than that.
Depends how many decimal places
But
you
you
work
could
to.
start at 3 and then sort of just if it's bigger and then.
You could. It'd be a rather sad way of doing it, though.
Like,
Has anyone got a graphics calculator that's told us the answer?
No, but I thought it was 18.
Yeah, 18m squared.
Where have I gone?
Oh, you put 6 instead of 96.
Oh, yes, thank you. So that's going there, isn't it? Okay. Okay, now you've taught me into going down this road. I want an answer from someone's calculator.
Can we trust the calculator?
If 2 people get the
Try
same
now.
answer, we'll trust them.
2.314.
We have a 2.314.
Is there a quick way to like define a function and then?
I don't know. I don't own a graphics calculator. They keep changing every few years and I keep buying new ones.
Right, so we go on the table and then we define this function. Right, this is genius.
Should I see what I get?
I mean, because there's only a certain number of numbers which it could be.
Yeah, I got 2.314.
2.314 again, somebody has. Okay, we'll assume that's the right answer then. That wouldn't have happened at A level, you wouldn't be expected to solve an equation like that. Williams from Lomax worked through all his possibilities from 3. If he's going up, he's going to be there for quite a long time. Okay, the only other thing I thought you might do was the standard deviation of x. How would we find the standard deviation of x? Yeah, simply square root the variance of x. The variance of x we had as 1.44 or 36 over 25. So it's either going to be 6/5 or 1.2,
It's
which
roughly 2.5, right?
happily are the same thing. So there we go. That's about everything other than working out probability that you need to be able to do for continuous random variables.